Hello, this is Walker Physics 4th edition. We're in Chapter 7 on work and kinetic energy. This is the end of the chapter questions, and we're in question 14. A small plane tows a glider at a constant speed and altitude. If the plane does 2.00 times 10 to the fifth joules of work to tow the glider 145 meters, and the tension of the tow rope is 2560 newtons, what's the angle between the tow rope and the horizontal? Okay, so if you remember, just using a little bit of trigonometry, that if you have the tension in the tow rope is this hypotenuse, if this is the tension, then that tension is not going in the same direction as the tow. The tow is going to be going this way. Constant altitude, constant speed. So the plane is not lifting the glider higher in the sky. He's simply taking the glider across the sky. So we want the portion of that tension that is moving horizontally. And then that distance times the force through that distance is called work. So the tension is only going to be part of the tension is the only part of the force is the force that we want. So we'll see that the opposite sign is going to be the tension times the sine of theta, and then the horizontal will be the tension times the cosine of theta. So when we have work equals force times distance, which is our nice easy formula, the force that's drawing that glider is the tension, which is the 2560 newtons times the cosine of theta, okay, times, we want the distance of 145 meters, and we want the work to be 2 times 10 to the fifth joules. Okay, so we'll have to see what is theta here. Okay, so when we take everything to the side, we'll have to solve for cosine of theta. So we'll take the 2 times 10 to the fifth, divide by 2560 equals, divide by 145 equals. So we end up with the cosine of theta is equal to 0.5387. Okay. Now that's not degrees, that is a decimal. So if you're going to find what theta is, you're going to have to take the inverse cosine. So 0.5387, second function, cosine. And we'll see that theta is going to be equal to 57.398 degrees. We're in how many significant figures? 3, 3, and 4, so 57.4 degrees. Okay, thank you.